All right, let's see how y'all did on these. The ratio test works well when? When does the ratio test typically work well? When we have things that grow, rapidly. Factorials and or exponentials, which means geometric. But never not first. Never not first for infinite series, the nth term test. What is the limit as n goes to infinity of our rule of sequence? Which one grows faster, the top or bottom? The top, right? If you just looked at the powers of the exponentials alone, 3 to the n grows faster than 2 to the n. It's kind of like x cubed grows faster than x squared. Not only that, n squared is in the top helping 3 to the n. And 3 to the n is like, dude, I don't need your help. But I want to be here. But I don't need your help. But I'm still going to stay here, okay? I'll help. Yeah. And it's got a plus 1, so it's like an extra 3 there as well. So this goes to infinity. Okay? Therefore, the series does what? Diverges. By the ratio test? No, by the nth term test. Now, I'm not going to go through it, but if you wanted to, let's say you didn't do that, you jumped right into the ratio test. Let's actually do it. If you do it by the ratio test, remember it's a two-way test, you'll get the same result. It's just a lot more effort. Oh, by the way, real quickly, what's that n squared we're down in the bottom, helping the 2 to the n? It would still diverge. Yeah, the n squared's like, you need help down there? I'm going to come help you down there. No, stay upstairs. No, I'm coming down. I want you down here. You're not helping. Okay, we're still going to infinity. Okay, just trying to find my place in the world. N squared. Let's go ahead and try the ratio test. We take the limit as n goes to infinity of the absolute value. It's a test for absolute convergence. We need the n plus first term. So that is just replacing all the n's with n plus 1. So we get n plus 1 quantity squared times 2 to the n plus 1, which is n plus 2, all over 2 to the n plus first. And then we divide that by the nth term, which means times, stay, change, flip, the reciprocal of the given term, the nth term, or the rule of sequence, whatever you want to call it. There it is, okay? And now we look to find a place to sit. Okay, there we go. Now we look to divide things out. So if you look at the powers of 3, let's do that first. You can just use the rule of exponents if you want. So you subtract exponents, right? So what's n plus 2 minus the quantity n plus 1? It's 1, right? So you're left with the factor of 3 in the top. Now let's look at the 2 to the n's. You actually have one more factor of 2 in the bottom, so we're left with the 2. All right, n minus the quantity n plus 1 ends up being negative 1, so we have a 2 factor in the bottom. And I don't think anything else factors out. So we're left with n plus 1 squared over n squared. Now, if you were to expand this out, this would be a quadratic over a quadratic, yes? Which means it would be leading coefficient over leading coefficient. Guess what the leading coefficients would be? 3 and 2. Okay, so the limit is 3/2. And by the ratio test then, since that is greater than 1, the series diverges by the ratio test. Okay, so for these two-way tests, if you don't see the nth term test right away, if it does apply, you're going to get the same result. All right? All right, so this one here, what do you think? Nth term test first. What happens to the nth term or the rule of sequence as n goes to infinity? It also goes to infinity, right? It also goes to infinity because the factorial grows faster than the exponential or the geometric. So this also diverges. And we could say by the nth term test. And we could do the same thing. If you wanted to, let's do the ratio test, just so we could practice manipulating it. We'll get the same result. The limit as n goes to infinity of. Now with the factorial, the n plus first term is going to be n plus 1 plus 1, which is now n plus 2 factorial, divided by 3 to the n plus 1. And then divided by the n factorial means times its reciprocal, 3 to the n over n plus 1 factorial. So to do a little bit of housekeeping, let's focus on the factorials this time first. Remember, to divide out factorials, you go to the one that's larger, n plus 2 or n plus 1. Which one's larger? N plus 2. And we write it in recursive form. N plus 2 times, we stop at n plus 1 because that's the factor in the bottom, so we tie it off with the factorial. Had that been just an n in the bottom, we would go n plus 2 times n plus 1 times n factorial, so that we get them to match. I'll just rewrite that one in the same spot. And then here's another way to handle the powers of 3 in this case. You can leave the top as 3 to the n, and in the bottom 3 to the n plus 1 is 3 times 3 to the n. So if you don't want to do it the way we did on the previous one, this is a more systematic approach. And now you have the fun. This one is fun, because now you can go and you're left with just n plus 2 over 3, which, of course, as n goes to infinity, you're left with infinity over 3, which is positive infinity, which I believe is greater than 1. Right, yeah, just a little. So the series diverges as well, additionally, but this time by the ratio test. Okay, if it's less than 1, it converges. If it's greater than 1, it diverges. And if it's equal to 1, inconclusive. If it's equal to 1, it's inconclusive. Got to try another test. But you watched the video. Okay, all right. I didn't put the link on the website. It's in the shared folder, though. Okay. Good. All right. Any comments or questions on the ratio test? It'll become one of the more important ones when we look for intervals of convergence for Taylor polynomials in the next few sections. Okay, so the last test is called the root test. And it's very, very similar to the ratio test because it starts with R. And it's also very similar in another respect. Here's what it says. Kind of the same thing. You're taking the limit as n goes to infinity, but this time you're not taking a ratio. You're taking the nth root of the absolute value of the rule of sequence. Okay, that's why it's called the root test. You're taking the nth root of the positive. It's another test for absolute convergence. And if that's less than 1, like the ratio test, the series converges. If it's greater than 1, it diverges. And it's also inconclusive if it equals 1. All right? So when would the root test be kind of useful? If you can write your rule of sequence as something to the nth power, okay, like a geometric sequence, the root test would be good. All right? It's not used that often. Okay? But if your sequence can be written as a power of n, the root test is hard to beat. Okay? Hard to beat. Like, what else would be hard to beat? Like Usain Bolt in his prime, right? Or Patrick Reed on Sunday. Or the New Braunfels football team, who once had a Montessera who danced for them that wasn't your sister. All right, example 21. Oh, never not first. The nth term test. We got a ratio there. Which goes faster, the top or the bottom, or the middle? Ooh, the top is exponential. Pretty impressive, right? E to the 2n, pretty impressive. If my money grew that way, I'd be happy. The bottom is Aleph, right? Queen of all growth. So the nth term test is inconclusive. But that means now we rolled up our sleeves, and I came to school with my sleeves pre-rolled up because I knew we were going to get into some good stuff. We got to try something else. Would this be a good candidate for the ratio test? That's going to be hard to simplify when you have n plus 1 to the n plus first power. So the Aleph function's existence in a series kind of triggers the root test. So let's see if we can rewrite the entire rule of sequence as a power of n. I think I could do it. That's going to be e squared over n all to the nth power, using the rule of exponents in reverse. Because remember, when we go this way, we have to then distribute that power to both things. So it would be e to the 2 times n and n to the nth power. So that's not geometric because you have a variable in there, but it is a power of n. So here's where the root test would be helpful. So let's take the limit then as n goes to infinity of the nth root of the square root of, we really don't need the absolute values because e squared over n is positive for positive n. So that's mainly for like an alternating series. If there was an alternator, you could just throw it out. So that's going to be e squared over n to the nth power. And now what is the nth root of something to the nth power? It's just that something. So we're just left with e squared over n. Okay, and now, what does that approach? E squared is a number, right? Like 3 squared. So 3 squared over infinity is approaching 0. Good. Which is less than 1. So the series does what? Converges by the root test. The root test. So yeah, n to the n grows so fast compared to e to the 2n that it pulls the graph to 0 fast enough for the sum to converge. Even though it's an infinite sum, it does converge to a number. We don't know what the actual sum is. We're not going to be able to figure out the number. We can approximate it with partial sums, but there's no error bound here. All right, so here's another one. And this one is obviously a power of n, right? You got something to the nth power. And it's not geometric because we have something on the inside that's not numeric. But again, never not first. The nth term test. What would be the limit of this as n goes to infinity? Well, what's the limit of the inside part as n goes to infinity? 3/2. So that's approaching 3/2, which is 1.5. What would be 1.5 to the infinite power? Would it be infinity? Remember, 1 to the infinity is indeterminate. Well, 1.5 to the infinity? That should be determinate, right? Because 1.5 is bigger than 1, so any power of that's going to make it bigger and bigger and bigger. Whereas 1 times 1 times 1 doesn't make it any bigger. So this thing should approach infinity, which means by the nth term test, no good. It diverges by the nth term test. But let's say you're like, I'm not sure. I don't want to trust that 1.5 to the infinity part. It's a good candidate also for the root test, which is a two-way test. So let's do the test. The limit as n goes to infinity of the nth root of 3n plus 4 over 2n to the nth power. And then, of course, the nth root of something to the nth power is that something. And now you could say, oh, that's 3/2, which by the root test is greater than 1. So the series diverges. This time by the root test. It's a two-way test. And maybe you're a little bit more confident with that result than, 1.5 to the infinite power. I don't know, that could be 7. Right? But it's not. It's infinity. All right, so the root test doesn't show up that often. But if you ever have an Aleph function or something that's just handed to you like that, you could use the root test. Let's try this one. How about from n equals 3 to infinity of negative 4/5 to the nth power plus 1th power. Bonus one. Determine if that converges or diverges by any method. By the way, the limit is 0, so the nth term test is inconclusive. Max is wearing his Spurs shirt today. Last night, the Spurs' victory clinched them what was going to be a doubtful 21st consecutive year of making the playoffs. But they did it. Whew. Way to go, Popovich. They're not going to get to the 50 wins, though. Hey, what's y'all's suspicion on this one? Converge or diverge? Your intuition, as I've been saying. Converge. It does converge, yeah. There's a couple ways to do it. If you want to use the root test, you got to be able to write it to the nth power. So here's one way you could do it. You could write that as negative 4/5 times negative 4/5 to the n plus first power. You can do it that way. Oh, to the nth power. Yeah. Yes. Thank you. Yeah, just to the nth power. That's the whole purpose of bringing the 1 out front. Thank you. Yeah. Sometimes I forget what I'm doing. Who are y'all people? All right. Then I could bring the negative 4/5 out front, just like you could with an integral. All right, so now I got negative 4/5 to the n. So I'm going to focus on this, and if that converges, then that times negative 4/5 is going to also be finite. So I'm just going to do the root test on that. The limit as n goes to infinity. The nth root of that to the nth power, can we save some time? The nth root of that to the nth power is this. Okay, I'm just going to save the nth root of that to the nth power. Well, what is the limit of a constant? A constant. Oh, by the way, it's got to be the absolute value. Yeah, okay. So that's 4/5, right? Because there's an absolute value in that. We want to take the absolute value of it. And 4/5 is less than 1. So the series converges. The series converges by the root test. Yay, way to go, root test. All right. How else could we do it? Well, here's another way to do it. Could you use the alternating series test here? Yeah, you could use the alternating series test. Here's how that would look. I'm still going to bring that negative 4/5 out front. And now I'm going to write that, although you wouldn't have to do that. I'm going to write that now as negative 1 to the n times 4/5 to the n. That's how you can separate the alternator from the magnitude contributor. That's the same thing. And now, because I have an alternator, negative 1 to the n, negative 1 to the n plus or minus 1, and of course, cosine of pi n is another one, we focus just on this part, and there were two qualifications. Does this go to 0 as n goes to infinity? It does. Do the terms decrease? They do. Okay, so you would show that. You would say the limit as n goes to infinity of 4/5 to the n equals 0, and 4/5 to the n decreases. You'd have to say those two things. So we know that it converges by the alternating series test. And then remember, if we wanted to approximate a sum, let's say I added up the first 7 terms to get an approximation of the sum, I know that that sum is going to be within what of the actual sum? If I use 7 terms, the 8th term. Good, the absolute value of the 8th term. The first unused term is the upper bound for the error. Okay. What if I wanted to find the actual sum? Well, that would require knowing the actual error, which I don't know. But is there another way to find the actual sum? Besides telescoping, which is not on the BC test, what's the only other one then that we can find actual sums for? Geometric. Is this a geometric series? It is also a geometric series. Yeah, very good. So if you wanted to cut to the chase from all of this, you could just say, what's up, geometric series? How's it going? Okay. It could be to the n or the n plus 1 or the n minus 1. The absolute value of r is the absolute value of negative 4/5, which is 4/5, which is less than 1. So it converges by the geometric series test. And as Devin asked yesterday, May 15th, you're going to write out geometric series test. Okay, sweet. Now, because it's geometric, we can find the actual sum. It equals the first term. And this is why we don't need to separate the negative 4/5 from the negative 4/5 to the n. I just find the first term by plugging in wherever we're starting, which is 3. So if you plug in a 3, you get negative 4/5 to the 3 plus first power, which is 4th power. All over 1 minus r. What's our r? Negative 4/5. So that's the thing there. If you have a negative value of r, it's going to become plus in the denominator. And this is, if you wanted to simplify it, that gives you your exact sum. Okay, pretty cool. So that one right there had 3 different ways that we've learned to show that it converged. But they all converge on the same conclusion, if you will, which is convergent. Sweet. All right, hard to beat. Like a slippery little kid. All right. Get over here. Let me beat you. Oh, I can't grab him. All right, that was me growing up. Yeah, I embarrassed my dad in the department store, and he wanted to beat me because that's what he did. Back then, everyone got beat. But I was slippery, and I got away from him. And there were some old people that were in the store. It was like JCPenney or something. I kind of like hid inside the clothes rack, you know. And they saw what was happening, and they looked at my dad and they said, "How rude!" And my dad got really upset and embarrassed, so he let me off in the store. But when I got home, whew, yeah, yep. And so I never did that in the store ever again. I learned my lesson. It was called discipline. I earned every bit of that one. Okay, all right. You see my dad nowadays, you wouldn't think he'd be capable of such violent swings with a belt. But wow, in his prime. Yep. Wayne. Putting it all together. Are y'all ready? We've got all 8 tests. Which tests are there? Well, let's jump down here. To help you remember all the tests, just think of Moses fleeing from the Israelites. Right? And Pharaoh. Yeah. What? Right? When they got to the Sea of Reeds or the Red Sea or whatever you want to believe, Moses parted the sea, right? He parted the sea, and then when the Israelites were on the other side, he closed it back up, and all the Egyptians died. Okay? Wonderful parable, story, whatever. Parting sea. If you remember parting sea like the letter C instead of SEA, then each of these stands for one of the tests. Okay? Yeah. P is P series. Is it in the form 1 over n to the P? Right? Remember, to converge, P had to be greater than 1. Because there's a lot of different things that you have to go with this, right? P has to be greater than 1. If it's less than or equal to 1, it diverges. And of course, when it's equal to 1, it's the harmonic series. The A in parting C is alternating series. Does the series alternate consecutive terms, plus, minus, or minus, plus? If it does, then are the terms getting smaller? And is the nth term going to 0? If so, convergent. If not, try another test. It's a one-way test. Okay? R is for ratio test or root test. Either one. We don't have 2 R's in there. Ratio or the root test. Does the series contain things that grow very large as n increases, like exponentials or factorials? If so, try the ratio test. And then for the root test, is it a power of n? Is it a power of n? In each case, if the limit of whatever, I'm just going to put parentheses there, if it's less than 1, it converges. If it's greater than 1, it diverges. So that's another 2-way test. The T is telescopic. Does it telescope? Can you decompose it into partial fractions, and then when you expand it out, does everything cancel except a couple of terms? Telescoping series. The I is the integral test. Okay? If you look at the rule of sequence or the nth term, is it something that you could easily integrate? And if so, are the dogs cussing in prison? Okay? This one has shown up on free response questions because they're looking to see if you know that dogs cuss in prison. Well, heck yeah, they do. You think they bark in prison? No. They're like, factor you and factor this and factor everything. They don't want to be there. Do you remember that the function has to be decreasing, continuous, and positive, right? Rachel's challenge. And then remember, then we could say that we get the same result. If the integral converges, the series converges, but to a different number. And if the integral diverges, then the series diverges. Same result. The n is in parting C is the nth term test. And although it's way down there, this is the first thing that you want to do. It's a time saver, right? It can be a big time saver. Is the nth term something other than 0? If so, diverges. It's the only one-way test for divergence. So you do it first. G is geometric series. Is the series of this form? Again, it doesn't matter if you start at 0. It doesn't matter if it's n plus 1 or n minus 1 or n minus 3 or n plus 11 or if you're starting at 12. It doesn't matter. Can you write it as a basically, we'll just put this here, exponential. Does it look exponential? Okay, you can have things in front that are multiplied by it, and you can have powers of n. Okay, if it looks exponential, then remember if the absolute value of r is less than 1, it converges. If the absolute value of r is greater than or equal to 1, it diverges. And then we have the sum is equal to the first term. I'm just going to write that over 1 minus r. That's the only one that we can really find the sum for besides telescopic. And then, of course, the C is comparison tests. We have direct or limit. Direct would be, is it one off from something? And then that one I'm not going to write it all out there again, but remember, if you compare it to something that converges, you have to show the given one is smaller. And if you're introducing one that diverges, you have to show the given one is bigger. Okay, so that is for the direct, you're going to have to show the inequality. You don't have to prove it, but you have to show the inequality. And remember, the limit comparison test is just if the limit as n goes to infinity of either one of them, a sub n over b sub n, or the other way around, again, is less than 1. That's the idea. If it's less than 1, it's going to converge. And is this a two-way test? Is that right? If it's less than 1, do they converge? I'm getting my tests mixed up. What's the result if it's less than 1? It's not less than 1. It has to equal what? Positive and finite. That was the result. It could be any number. This is the only one where the limit doesn't have to be less than 1 because you're introducing a separate function. As long as it's positive and finite, they have the same result. So it is easy to get them confused. They either both converge or they both diverge. All right. This one works well when it's not one off or the inequality is not maintained. And remember, what you're really doing here is you're getting the powers the same. It's going to end up being leading coefficient over leading coefficient when you end up doing it. All right, and that's it. And then for the alternating series, we'll just throw in here, remember, you have the idea of is it absolutely or conditionally convergent? And then you have the error bound. There is an integral test error bound, which is not on the AP exam yet. It might be in a couple of years. But remember, the error bound is just the absolute value of the first unused term. Okay, so parting C can help you remember the tests. Let's go through it then on example 22. And I'm not going to get into writing it all out. We're just going to kind of maybe say if it converges or diverges by intuition, and then just state what the test would be, okay? So this one here. These are all infinite series, by the way. They're all going to infinity. But you got to be careful. If that is like a 5 up there, then it's going to obviously be a finite sum. All right, what do you think about this series? Converge or diverge? Converge. I think it diverges. Yeah. This is one where you could do a limit comparison test. This is a good candidate for limit comparison test. You have to find the leading terms, which remember are not always in front. And 1 n cubed over 1 n cubed, actually you would compare that to a constant which diverges. So you don't even have to use the limit comparison test here. What is the limit of the nth term of the rule of sequence? It's 1/4. So this would actually be an nth term test. Or you could use the limit comparison test. But remember, when you determine what to compare it to, you divide out your leading terms, which is 1/4. So if you compare it to 1/4, the divergent number series, I don't even know what to call it, 1/4 plus a fourth plus a fourth is going to diverge. You could show that it also diverges when you compare it to 1/4. Okay? But the nth term test is a time saver. Okay, so we're going left to right. Letter B, 2/7 to the n. Root test or geometric series is a good one. Yeah. Converge or diverge, though? Converge, right? Yeah, it converges. The root test works well. The geometric series works well. This one, you might be asked to find the sum. So let's go ahead and write the sum while we're here. The sum would be, we'll just say S equals, the first term is what? 1. You're starting at 0 this time, so 2/7 to the 0 is 1, or 1 minus 2/7. And you could actually simplify that one. 1 minus 2/7 is 5/7, so that ends up being the reciprocal. 7/5, yeah, what a handsome little sum. 1.4. You go 1.4. Keep striving, you could be 1.5 in no time. Never, ever. You're 1.4 forever. But it was a good motivational speech, right? Comments, questions? So far, so good? So good so far? All right. Letter C. Converge or diverge? Let's do that first, and then we'll talk about the test. Converge. This one converges. Good. Because remember, your intuition is going to take you far if these show up on multiple choice questions. So this is convergent. If you bring the 4 out front, which you're allowed to do, this is a straight up what? This is a P series. Yeah, P series. If that were like an n cubed plus 1, it would still converge, right? And now you'd probably use the limit comparison test, right? Or you could use the direct comparison because n cubed plus 1 is smaller than 1 over n cubed. Either way. But the plus 1 wouldn't really change things. What if it were plus n squared? Would it still converge? Yeah, and then you could still use the limit comparison test if you want. Okay, cool. Moving right across. A, B, C, D comes next. N squared over 5 to the n. Convergent. Very good. Intuition serves you well. That's convergent. I'm going to write them in front of the sigma each time. All right, what test would you use? The limit comparison test is not going to be good here. Ratio. Good. You have an exponential in there. Okay, it's not purely geometric because you got the n squared at the top, so the ratio test would prove it. All right, ratio test. Letter E. Converge or diverge? What verge? Diverge? Let's see, it's growing. If you look at the leading terms, it's growing like a 1 over n to the 5/3. That's going to be what you would compare it to if you did the limit comparison test. And it's, what that actually does what? Converges, yeah. So this one actually converges because the power is greater than 1. And you would do a limit comparison test with 1 over n to the 5/3. And that would give you leading coefficient over leading coefficient. That one actually converges. Now, if it were the 5th root of n cubed, which could really easily mess with your mind, what if it were that? What if we flip the powers around? That would now diverge, because now it grows like 1 over n to the 3/5. That would be a divergent P series, and then you would still use the limit comparison test for that. Okay, sweet. So this one would diverge. A, B, C, D, E, F comes next. Oh, it's a good one. I like this one. This is my favorite one. Letter F for favorite. Coincidence, totally coincidence. What does y'all's intuition tell you? You think it's going to converge? Well, let's see. If it were just 1 over n, that would certainly do what? Diverge. Now remember, the spirit is, if I can help the denominator along a little bit to help it grow a little faster, it's going to converge. So if that were like 1 over n to the 1, to the 1 point, why does this do this? Stop. No. Stop. Go away. All right. If that were 1 over n to the 1.0000000, keep going 1, that would be enough help to make it suddenly do what? Converge. To a big number, but still convergent. It's kind of interesting. If it were just 1 over the natural log of n to the 4th, do you think that by itself would converge or diverge? If you remember your sequence of growth rates, 1 over n is a power function. Logs grow slower than power functions, don't they? So do you think natural log, with all of its fortitude to the 4th power, can get enough momentum going to converge? No, it's probably going to diverge, more than likely, because logs grow slower than power functions. But what if you teamed up? 1 over n doesn't go fast enough. If you throw a log down there, is that equivalent to giving it enough boost by increasing the power to make it converge? Does natural log help it along enough to make it converge? That's a good question. It's not really intuitive, is it? This kind of gives you a gray area. So let's actually work this one out. I like this one. What test could we use on this one? If we did a comparison test, it would be hard to know what to compare it to. 1 over n diverges. We would have to show that the other one is bigger, but it's not because we have more in the numerator, makes it smaller. So the comparison test is not going to work, limit or direct. Any other ideas? What other tests do we have? Parting C. It's not a P series straight up. Comparing it doesn't work. Alternating series, no way. Root test, ratio? No. Telescoping? I don't think so. Well, that would be part of alternating series. Yeah, there's no alternating there. Where was I? Integral test. Oh, integral test. That's showing some promise. If this were 1 over x, ln of x to the fourth, is that something we could integrate? Let me write it like this. 1 over x times the natural log of x to the negative fourth. Is that something we can integrate? Yeah, all day long we can. So before we jump in and do that, are dogs cussing in prison? Is this function decreasing? Yeah, the terms are getting smaller. Is it continuous? It's not defined at 0, but we're starting at 2. So it is continuous over the interval defined. And is it prison? Is it positive? The terms are positive. Yeah. So you would have to state those on a free response. 1 over n to the ln, this, you're talking about this now. The rule of sequence is decreasing, continuous, and positive. You only have to state that. Again, you don't have to prove it. We verified it. And so now we can go for it. That means that they're going to have the same behavior. So since the derivative of ln of x is 1 over x, we're not off by anything, right? So the 1 over x gets packaged back up, and we're on to the rule of integration, which is blob to the negative fifth. Oh, this takes us back to 4.4. Blob to the negative fourth becomes blob to the negative third, and then we divide by negative 3 or multiply by negative 1/3. And then we evaluate it from, oops, I forgot to put my intervals of integration. We're going from 2 to infinity. So 2 to infinity, 2 to infinity. If this were a free response, remember we can't just leave infinity up there. It has to come from a limiting process. So let's go ahead and say it's from 1 to b, and we'll take the limit, or 2 to b, thank you, old habits. I still try to smoke every day, and I can't because I'm so used to not smoking. I can't start. I just can't start. It's hard to start. Let's evaluate it. We got the limit as n goes to infinity. I put b. Good. Thank you. See, it helps. I'll be right there with you on the actual AP exam. No, I won't. I won't be there to mess you up. That should give you confidence. So I'm going to write that as 1 over the natural log of b cubed minus 1 over the natural log of 2 cubed. And now we evaluate it. There's only one b term, and there it is. The natural log of b goes to infinity. Infinity cubed goes to infinity. What does 1 over infinity go to? 0. So this ends up being negative 1/3 times a negative, which makes it positive 1/3. We can just write it like this. 1 over 3 natural log of 2 cubed. Or, if you want, no, you can't, you have to leave it like that. That's just a number. So, that's finite, which means that the integral converges, and therefore, so does the series. So, we're going to say, so both the integral and the series converge by the integral tests. Okay, so that was really kind of neat. So yes, the natural log does help out the 1 over n enough to get it over that infinity hump and make it converge. Pretty neat, pretty nifty. Okay, so that was a good one, integral test. All right, getting back on track here. Oh, by the way, just to review the error bound here, if you wanted to figure out, let's say you added up the first 7 terms, that sum of the first 7 terms would be within the integral from 7, not the next one, but the same number, 7 to infinity of the actual sum. You'd have to do a little more work there. Okay, letter G, converge or diverge? We have an n squared over an n cubed, so the nth term test is inconclusive. It diverges. If you simplify those leading powers, it becomes 1 over n. So this thing is going to grow for large values of n like 1 over n, which diverges. And of course, you would prove that by using the what? Limit comparison test. Yeah, limit comparison test. No, you don't have to do long division. You just remember the limit comparison test. You take that and you divide it by 1 over n. You state 1 over n diverges. And then you state change flip, and it becomes 5n cubed minus who cares? 6n squared plus 3n over 1n cubed. The limit then is 5, which is a positive finite number. Therefore, both series diverge. Yeah. You can always just simplify the leading powers to get essentially the effective growth rate. Remember when we talked about that? Kind of the same idea. A, B, C, D, G, H comes next. All right, how about this guy? Converge or diverge? Well, if you just looked at 1 over n to the 1/2, that would be a divergent p-series. What does the cosine of n pi in the top have? That just hangs out between 1 and -1, doesn't it? That's the amplitude. But it is an alternator. Aha! There you go. It alternates signs. When you plug in a 1, you get pi, which is -1. Plug in a 2, you get 1. So that is your tricky, sneaky alternator. So now, in the presence of the alternator, 1 over n to the 1/2 does go to 0 and does decrease, and therefore this series does what? It converges with the help of the alternator, which subtracts out every other term. It actually converges. Conditionally or absolutely? Yeah, this one is conditionally convergent. If you got rid of that alternator, that sneaky alternator, now it's diverging. Okay? So that's conditionally convergent. So beware of the tricky alternator. You also want to beware of an alternator. If it was like -1 to the 2n plus 1, is that an alternator? Yeah, if you're not sure, you can start expanding out some of the terms, or you can simplify that. That's the same as -1 to the 2n times -1 to the first, yes? Well, what is -1 to the 2n? That's -1 squared to the nth power times -1. What's -1 squared? 1. What's 1 to the n? 1. 1 times -1 is -1. Is that an alternator? If it's -1 all the time? No, it's not. So 2n plus 1 looks like an alternator, but it's not. Now, it's a little bit faster. If that ever shows up, if you just expanded the first two terms, you would see they would both be negative. Okay? Because remember, 2n plus 1 is an odd number, right? It's an odd number. And -1 to an odd number is always negative. So beware the tricky alternator that's not an alternator. It's got to be something that simplifies down to -1 to the n or -1 to the n plus or minus 1. And then we have that tricky alternator cosine of n pi. And then rarely, I've never seen it on AP exam, but remember it could be multiples of pi halves. So it could be pi halves n. That's another alternator. So beware the alternator. That one's conditionally convergent. Okay, sweet. Letter I. Diverge or converge? Diverges. What test? Nth term would work, or what? Comparison? Yeah, comparison would work. You would compare to geometric series, 3/2 to the n. Good. I would say limit comparison test. Or, what else would work? Well, the root test would work if the plus 4 wasn't there. How about the ratio test would also work? The easiest, though, is the nth term test. 3 to the n over 2 to the n goes to infinity, so that's a time saver. But it is one off of a geometric series, and you would be able to say that 3/2 diverges, so 3 to the n plus 4 is bigger. It also diverges. So you could do a direct comparison there, actually. Direct. But again, the nth term test saves some effort there. J is next. Converge or diverge? The series. We got an n to the 5th over an n to the 5th. The limit of the rule of sequence is 2/3. Is that equal to 0? No. So because the sequence diverges to 2/3, the series, or converges to 2/3, the series diverges. The series diverges by the nth term test. Remember, if the rule of sequence does not go to 0, it is game over for the sum. The sum has no chance at converging if you're just going to be adding 2/3 forever and ever and ever at some point, right? It gets smaller forever. It's a small amount to add, but it accumulates over time. The power of compound interest. All right. How about this dude, this fella, this chap, this homeboy? Converge or diverge? Converges. Yeah. If you simplify on the inside leading powers, you get the square root of 1 over n to the 4th, which is 1 over n squared. So that's its relative growth rate. 1 over n squared would be a convergent P series. So this one converges. And then if you had to prove it, you would use the what test? Well, you would compare it, right? You would compare it to 1 over n P series, but this is not a one-off comparison, so this would be a limit comparison. When you divided by the square root of 1 over n to the 4th, you would end up with 3n to the 5th over 1n to the 5th. The limit then would be the square root of 3, which is a positive finite number. Okay. Letter L. Converge or diverge? Very good. That might be, we've already seen that. 3 to the n grows faster than 2 to the n, yeah? So if it were just that, and the minus 1 doesn't matter because that's just like pulling out a 1/3. So this would diverge, right? But you have a helper in the bottom, right? You think the power of n is going to help 2 to the n catch up with 3 to the n? Probably not. You're right, it probably does not. Yeah. That really only happens on the cusp. Remember, on the cusp of things that converge or diverge. The cusp of convergence and divergence is 1 over n. That's where things differentiate. 3 over 2 to the nth power, 3 to the n grows so much faster than 2 to the n that you're not going to be able to help out 2 to the n in the bottom. That could be an n to the 50th power times 2 to the n, and it still doesn't help 2 to the n out enough. Okay? So to train your intuition, it diverges. If you wanted to prove it because you were not sure, this would be a good candidate for what? Ratio test. Right. We don't generally do limit comparison tests with exponential, with geometric. So if it's a comparison kind of feel, but it's geometric or exponential, go with the ratio test. Okay? The ratio test will show that. And that one's a good one. Maybe if we have time, we can come back and work that one if we don't get interrupted for taking a stand. How about this guy? Converge or diverge first? Divergent is right. You could do the ratio test. No, the root test. That's what y'all said. Yeah, the root test works great because it's obviously a power of n. But also what else works? The nth term works nicely as well because the limit of this is 2/5, and 2/5 to the infinity power we already saw equals infinity, which is not 0. But the root test works just as great because you get rid of the n, and now you get 2/5, which is less than 1. Oh, hang on. I said diverges. Yeah, I didn't mean that. Good thing I actually went through the test. I just misspoke. It's 2/5 to the infinity. My bad. I don't know why I said that was equal to infinity. 2/5 times 2/5 times 2/5 is 0. Yeah, it actually goes to 0. So then the nth term test does not work. And the root test would show that 2/5 is less than 1, so this actually converges. Yeah. Or you can use your intuition, kind of the same result that we saw over here, where the 3 to the n overpowered the 2 to the n. No, where was it? Over here. The 3 to the n overpowered the n times that. It works the other way right here. To the flag of the United States of America, to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Pledge allegiance to the one state under Texas, indivisible God.
Please remain standing for the moment of silence.
you have a great day.
Yes, we will. Okay, so pardon my overexcitement. I'm seeing the clock. I'm thinking we're going to run out of time, and I, in haste, made a careless, intuitive mistake. But then when you actually do the test, you confirm it. So, yeah, I have been going too fast. So M indubitably converges. Yes? Any questions on that one? Root test is an easy one to prove it. All right, N. Here's where we are. We have seen N like this in this manifestation of it? Oh, very good. If this were the natural log of N to the nth, and it was like this, then you can bring the N to the front. But this is the whole thing to the nth power. Yeah, so we can't bring that to the front. The nth term test is inconclusive because the limit of the sequence is 0. Is this another good candidate for the root test? Yeah, you could say it's 1 to the n, right? So you could say it's 1 over the natural log of n to the nth power, then take the nth root of it, which means you're left with this. And what would be the limit of that as n goes to 0? As n goes to infinity? It'd be 0, right? And 0 is less than 1. So this one converges. Yeah, this one converges by the root test. Right? Which is kind of tricky because you might think natural log grows pretty lamely, right? But notice the power is not a constant. The power is n. So you're kind of introducing the idea of the Aleph function there. All right? If that were just 1 over the natural log of 100, now what would you think? Would you still think it converges? No, now it actually diverges. And you could do a direct comparison with 1 over n or something like that. It doesn't grow fast enough. But because it's to the nth power, so the root test works great there. All right, how about this dude? Yeah, this is one that you might want to just commit to memory. The limit as n goes to infinity of the quantity 1 plus 1 over n to the n is what? E. Yeah, that's a pretty famous thing. So the limit as n goes to infinity of 1 plus 1 over n to the n is equal to E. But that means then that the series does what? Diverges, okay? Because the terms are approaching E, you're going to say plus E plus E plus E, right? Which is E, right? 3 plus 3 plus 3-ish. Yeah, so be careful. Again, the difference between a sequence and a series by the nth term test. Nth term test. Okay, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. We're at P. I see the alternator. I see him. There he is. So now you analyze what's left. Does that go to 0? 1 over ln? Does it go to 0? Not that quickly, but it does go to 0. It does go to 0 because the numerator is 1 and the denominator goes to infinity. Very slowly, but it does go to 0. Is 1 over ln of n decreasing? Yes, it is decreases. So it decreases. So in the presence of the alternator, this one converges by the alternating series test. Do you think it converges without the alternator? No. Okay, again, no. 1 over ln, that would be one that you could easily prove by comparing it to 1 over n directly, because ln of n is smaller than n, and therefore the denominator is smaller, which makes it bigger. So this one actually is conditionally convergent. So that's kind of interesting. 1 over ln by itself pathetically diverges, but subtract every other term forever and ever and ever, and you make it small enough to become a large but still finite sum. All right, pretty cool, pretty cool. Let's go ahead since we don't have time. We don't have time. We have like 2 minutes. Okay. You might want to verify that one on your own. That was the one that was kind of iffy because we had n helping out the 2 and n in the bottom. And that same idea was enough to get 1 over n over the hump when it was ln. But that was on the cusp, on the precipice of converge diverge. You'll see for yourself that this one does the opposite. All right, so we're done. There's a lot to keep track of here. these show up a lot as multiple choice questions, okay? So a lot of times you can rely on intuition. Yeah, we can do homework Thursday. I don't care. It's fine. Worksheet due Thursday. That gives you an extra day. I don't care. You know what my deadline for y'all is, right? May 15th. May 15th. Okay. But we are starting 9.2 tomorrow. Yes, yes? And quiz? Well, you know what? If it was like a take-home quiz, maybe. But I don't want to squander time for that in class. Yeah. So maybe I'll come up with a take-home quiz. Okay. Enjoy the rest of the